Hello viewers, welcome to another problem solving session of the channel Big Boy Physics, and today's problem is based on the topic of envelope and fluid mechanics. This problem I have taken from 200 Estonian problems. It's from the archive, means that is the previous Estonian physics Olympiad problems. So let's get started. Small holes at numerous different heights have been made into the wall of a vertical cylindrical vessel, and water is flowing out of them. Additionally, water is slowly poured out of the vessel so that the water level inside the vessel is constantly at a height H. Then find the region of the room can the exiting water reach. In other words, express the equation for the envelope of the water spurts in xy coordinates. Assume that different water spurts do not affect each other. So this is the question. Now they are also saying that we are keeping the capital H, that is the height of the free surface of the liquid, at a constant distance from the bottom of the vessel. Pause the video, give it a try. So let's get started. Well, if you remember about finding the envelope trajectory of different parabolic trajectories, when we throw a ball, then the point at which the ball is there is the focus of the envelope, and the maximum height is the vertex of the parabola. And if you extend the line connecting focus and the vertex at an equal distance, then you will get the and draw a parallel line to the axis, then you will get the directrix. But in this case, we are asked to find for different focus, means for different value point of projection. Now in that case, if you remember, we actually solved a quadratic. We solved the quadratic and put the discriminant equals to 0. Let's see what we can think for this problem. So we are asked to take this point to be 0 comma 0. Okay. Now suppose at an height h there is a small hole, then the velocity of the water flowing out of the hole will have horizontal velocity root 2 gh. Now after time t, after time is equals to t, x coordinate is equals to root 2 gh into small t, and y coordinate is equals to h plus half gt square. Now putting t is equals to x by root 2 gh, you'll get x square by 2 gh into g. From here you'll get y is equals to h plus x square by 4h. Now what is this? This is the equation of trajectory. Well, this actually represents the equation of trajectory of the given curve. So on further evaluation, you will get 4h square plus x square minus 4hy is equals to 0. Hence, you'll get 4h square minus 4hy plus x square is equals to 0. Taking it as a quadratic, it is a quadratic in h, small h. Now you have to find the possible value of x and y so that we can get one root of h. Then for getting such root of h, then the discriminant should be greater than equal to 0. Does it imply that 16y square minus 4 into 4x square is equals to 0? We are putting discriminant d is equals to 16y square minus 16x square is equals to 0. From here you'll get the equation y is equals to x, or y is equals to y plus x is equals to 0. Okay, so it basically represents either two cases. It's either like this or like this, whatever. So using your brain, you can say that the required equation will be y is equals to x. So I can say that y is equals to x is the required envelope, and that's the answer to this question. So one thing we got to know about regarding this question, that if you want to find the envelope, then you have to consider a parameter, and you have to take the all real possibilities of that parameter. Okay. And another way to solve this question, I would like to discuss with you that for envelope to exist, the boundary of envelope and the given equation touches each other. Basically, the boundary of the envelope and the given equation touches each other, which means that this equation will have repeated roots. This is another method to do, and you can also apply that in the trajectory problem in which we found out the envelope trajectory. Now to do this, we'll be differentiating this equation with respect to h. Here we'll get 8h minus 4y is equals to 0, and put h is equals to y by 2. Putting h is equals to y by 2, you will get um, y square minus y 2y square plus x square is equals to 0. From here you'll get x minus y equals to 0 or x plus y equal to 0, and these two are the required solutions to the given problem. Okay. For you can understand, you can realize that my answer would be basically x is equals to y. So x equal to y is my answer to the given problem. Hence it implies, this problem basically implies that if this is my vessel and this is the free surface, suppose this is my ground and this is my coordinate axis, then this is the envelope of the all possible parabolas, and water will remain in this portion. Yeah. Now advanced or any other olympiad like questions, they will make a variation like, if you have to find the area covered by this kind of a sprinkler, assume this to be a sprinkler, then if you want to find the maximum area which can be covered, then you can just take it like this. Suppose this is radius r and the height to which it's filled is capital H. This will be h again because the slope is 45 at an angle 45 degrees. The line is at an angle 45 degrees, or the envelope, since the slope is 1. So you can say that area covered is pi r plus h whole square minus r square. Now considering it as a very thin cylinder, okay, considering it as a very thin cylinder, well, this approximation won't be very good because already the hole is very small, and the thin cylinder would make the area of this cross section to be comparable to the areas of the hole. That is why it's not that effective. But yeah, but it's a good approximation. If we consider that this vessel's cross section area is greater than the dimensions of the hole, suppose hole dimension is small d, is much less than small a, means small a, basically the whole area is small a, we say a much less than capital A, much less than h square, something like this. Then for this approximation we can take this nearly to be pi h square. So that's all for today. Hope you enjoy this problem, and I'll be taking up numerous problem even if I get any alternate solution to this problem using geometry which I am currently finding. I will be sure to post it in the YouTube channel later. Thank you and have a nice day.